Griselda, or someone to just confirm that you can hear me and see the slide clearly enough,
Yes, we
and
can.
then we can kick off. Thank you very much. All right. So I thought about doing something a little bit different. We're so tired of speaking about COVID and maybe even healthcare policy, even though there's lots to talk about there. But I thought it might be useful to talk a little bit about what we can learn from Bayesian probability theory, because it's quite topical. I think it's quite interesting. And I also think there are some lessons that are relevant to the current times. And personally, I've always been a fan of that kind of murky, controversial area where mathematics appears to intersect with ethics and morals. If you can believe that, we can learn some moral lessons from mathematics and probability, or so I believe at least. So I'll start by just pointing out that, Bayes is one of those theorems that's simultaneously super profound and, in hindsight, absolutely obvious. As you grow older, I guess you start to realize that some of the most profound truths in life are perhaps paradoxically also, at least in hindsight, some of the most obvious ones. And I'll show you a little bit later that when Bayes stumbled across this theorem and wrote it down, he actually never thought it was necessary to publish it. He didn't think it was worth publishing. It was only discovered posthumously, and the true significance of this, which I hope to show you today, only was revealed after Bayes died, because he didn't think it was profound enough or worth publishing. So what are we talking about? I guess I want to appeal to your intuition and ask some questions about probability, which is like the kind of stuff that actuaries talk about when we have a braai or a beer. So we talk about probabilities all the time, of course. But let's imagine that you throw a dice 10 times, and every time it lands on a 6. So 10 sixes in a row. Now, when we went to probability school, many of you had Statistics 101. If you didn't, you would have heard this before. It doesn't really matter what the history is of throwing a die. When you throw dice, the result will be 1 out of 6 chance for any number to be revealed. So if I take this die that I've just thrown 10 times in a row, got a 6, 10 times in a row, the conventional mathematical view of probabilities is if I throw this dice again, the chances of getting another 6 is also 1 out of 6, because there are only 6 sides to the dice. But I'm sure inside of many of you, there's something stirring if we say this. Hang on, that can't be right, If we throw it and we get 10 sixes in a row, doesn't that mean that there's a better chance of getting another 6? Or does it mean that there's a worse chance of getting another 6, Because on the one hand, you might say, okay, well, maybe this die is weighted. Maybe this isn't a kosher die, and it's going to give me a 6 more often than not, and that might be true. Or on the other hand, if you believe in the law of large numbers and probabilities, and you know that if you do this many, many times, you're going to get an equal number of 6s and 1s and 2s and 3s and 4s and 5s, then at least at some point, the 6s need to be compensated for with other observations. So maybe if we throw it again, the probability is not 1 out of 6. Now, this kind of question that will encounter you in everyday life quite frequently, whether you go to a casino, which of course none of us never do, or whether you take bets on the outcome of a sports event. This kind of probability seems to be a little bit more intuitive. And so because of this kind of stirring that you might feel inside of you when I ask this question, there are 2 schools of thought on how probability works. First, we have the frequentists, which is a word. We can joke about physicists being frequentists using statistics. That's really funny, but when you make a joke over Zoom, you never know whether it is. But frequentists say that probability tells us about an objective characteristic of the universe, of how the world works. It tells us about the chance of something, and it is an objective, verifiable fact, or at least conceptually verifiable, because frequentists argue that you need to do an experiment an infinite number of times. And if you do it an infinite number of times, you can look at the proportion of outcomes in each one. So if you throw a die an infinite number of times, you'll get every result roughly or exactly in infinite terms, 1/6 after time, and hence the probability is 1/6. So this sounds a little bit academic and a little bit silly, but this has actually been tested. This poor bloke with the name of John Kerich spent some time in a Nazi war camp. I think it was from Denmark, if I remember right. And he actually did experiments with ping pong balls and with coins. And he did actually flip a coin 10,000 times and meticulously wrote down the results of this experiment. Understandably, he was quite bored at the time, but on the left, I have an excerpt from a paper that he later published. These are the first 2,000 results of flipping a coin, with a 0 denoting tail and 1 denoting heads. And he did actually get very close to 5,000 out of 10,000 heads versus tails. So the frequentist approach showing, if we can experimentally or empirically prove that this is how probability works. It's fascinating to look at the results, by the way, got nothing to do with what I want to talk about today, but one of the traits of probability that human beings often don't fully apprehend in our own intuitive reasoning around it is just how frequently it can happen that you get many heads in a row or many tails in a row. If you look at some of the results, just eyeball some instances where you get many ones or many zeros in a row, more, quite often much more than intuition would suggest. I'm sure some of the medical scheme people in the room can relate to like bouts of high cost cases emerging in succession, to the frustration of many. But randomness is sometimes like that. All right, but I'm sure, if we talk about the frequentist approach, you'll agree it's kind of interesting and academic, but not really useful because we can't always do something an infinite number of times. So, if South Africa won the Rugby World Cup, that's great. We can say, what were the odds? And that's a really strange question to ask. What were the odds that we won? We will often talk about the odds of the outcome of a rugby match, but the frequentists would say, well, if you want to do this, just play the rugby match an infinite number of times and then we'll know. Well, that's not really useful, is it? We will only do this experiment once ever. The result will be a win or a lose. And in hindsight, it will feel kind of silly to say what were the odds, but this is something that we often talk about, isn't it? We use the language. We think the odds are great. We think the odds were stacked against us and yet we won. But what does it even mean to talk about that in retrospect or prospectively? So there is another school of thought. So I said that the frequentists think like mathematicians and they believe probabilities are exact and objective truths. But we have another camp, which we'll talk about today, which is the Bayesians, and named after Thomas Bayes. So Bayesians believe that probabilities are really expressions of your state of belief. And that's an interesting word to use when you talk about maths, is beliefs. Bayesians would say that probabilities are subjective. These beliefs are personal. You would go into the Rugby World Cup with a prior view, say, I believe the chances of South Africa winning is X or Y. And one important characteristic of Bayesians is that Bayesians will always ask, well, I think I know this and I believe this to be true, but how certain can I be that I'm correct here? How true is this? And examples of areas where Bayesian approach is much more useful than the frequentist approach, of course, would be something like the outcome of an election. So we can now say, before the election, I thought this one might win, or I thought it would be closer than it was, but now we've run the experiment. And this is an experiment by definition you can only ever run once. And the results come out and they say, okay, well, maybe I was wrong or maybe I was right. And this is, this is what the odds of the experiment means. Or surgery, I think is useful. I once talked to a very experienced surgeon who told me this rather quirky story. He said he kept meticulous statistics throughout his practice of the success rates of a certain procedure that he did quite often. And his own statistics revealed that the success rate of a particular procedure was about 85%. But he said to me, whenever I consult to a patient and discuss the possibility of performing the surgery, I would say to the patient, look, sir, madam, the odds of success historically of doing this procedure successfully is about 85%. And I think we should do the surgery on you, but I want you to know that if I do the operation on you, the odds of success is only 50%. Now, that's of course not entirely correct. It's actually completely wrong. But I think what the specialists try to convey to the patient is, look, you're going to come into the hospital, you're going to go into theater, we're going to put you to sleep and do the procedure, and you're going to wake up, and it's either going to be a success or a failure. We can only do this once. And if you wake up and it was a failure, then this notion, this understanding that there was an 85% chance of success is really of very little academic usefulness to you. You're just going to wake up with either a success or a failure. And it tries to convey that kind of personal subjective experience of probabilistic outcomes to the patient through this narrative. So let's go into Bayes a little bit more detail. Bayes was a Presbyterian minister, if you can believe it. He was a statistician and philosopher back in the 1700s. The only picture we have of him is this one, which might not even be the correct picture. He only published 2 works in his academic life. And the one that we're talking about today was never published because he didn't think it worthwhile. Actually, after Bayes passed away, his family contracted his friend Thomas Price to work through his scribblings and unfinished notes. And during a 2-year period, Price did this and discovered this one theorem called Bayes' probability theorem. He realized the significance of the theorem. Interestingly, he actually believed, Thomas Price, that he could use this theorem to prove the existence of God. And I guess it shows you how close probability kind of moves to the area of belief. And he presented this to the Royal Society that Bayes also belonged to, but never presented this to in December 1763. So maybe the simplest way for the current audience for me to talk about Bayes is to talk about something that Gary talked about in an earlier Foresight, which is sensitivity and specificity. I don't know why we have these words like specificity and frequentism, these S words in today's presentation, but specificity. If you're bored with my talk, try to say specificity 3 times very, very quickly. And maybe you'll be a little bit less bored. But let's imagine that you've tested positive for a really, really bad terminal, but a very rare disease. And Gary has done this before. So please, many of you would understand this quite well, but I want to use this as an example of where Bayes is applied in practice. We have the specificity of the test is 99%, which means the odds that the test will tell you you are positive if you are in fact really positive is 99%. It's quite an accurate test, but it's a rare disease. Let's imagine for the sake of our example that only 1 out of 1,000 people have the disease. And we can work through the maths now. So I'll bore you a little bit with mathematical formulae. It's much more simple than it might look. And actually some of you will think it is too simple to warrant the discussion that I go to, but I'll explain. This is about the profundity and the obviousness simultaneously. So in probabilistic notation, we would say the probability of H given E, that little black bar means given that. In other words, there's a hypothesis H that I have the disease, there's some evidence. The evidence is I have tested positive for the disease. So the probability that I have the disease given that I've tested positive. And Bayes said you can calculate this by looking at the probability that you have the disease overall, multiplying it with the specificity, or we can also express the specificity as the probability of testing positive given that you have the disease. If you swap the E and the H around, divide this by the probability of testing positive overall. So this is really boring and uninteresting, but bear with me. To calculate the probability of testing positive, it's often practically much more simple to say it's the sum of a false positive plus the false negative result. That would be the probability of testing positive. And we can work out these numbers actually. The first and most difficult one to plug into the formula is the probability of having the disease. And we call in Bayesian terms this your prior belief. Before you have the test, what did you think were the odds? And this is interesting. Bayes often talk about what do you think, what do you believe, What could it be according to your own subjective view? And different people have different prior views. Griselda, I'm picking up some sirens and background noise. I'm not sure where it comes from, but maybe you can just try to mute, or it might be Barry, just to help a little bit. Thanks. So this often the hardest part is to come up with a prior probability. In our case, for this example, let's just assume that if the prevalence of the disease is 1 out of 1,000, maybe a good prior point to start would be to say, okay, the chances of me having the disease is 1 out of 1,000. We would multiply that by the specificity, and we can crunch the numbers at the bottom. Those are the results of having a positive result, which is about 1.098%. If you've got a false positive and a correct positive result, and that gives us, if you crunch the numbers, a result of 9%. So the interesting and maybe counterintuitive part, which Gary also illustrated earlier in Foresight, is that even though the specificity, or in layman's terms, the accuracy of the test is really, really high, because the prevalence of the disease is so low, we can actually only say with 9% certainty that I have the disease if I tested positive for it. I can show this graphically. Maybe for those of you who think it's counterintuitive, let's imagine 1,000 people. So this slide has 1,000 blocks, and because I'm lazy, I only drew 3 people, but imagine 1,000 people. And if it's true that the prevalence is 1 out of 1,000, then maybe 1 of the 1,000 people have the disease. But if you test, there's a chance of a false positive result. And out of 1,000 people, there are actually, because we have 1,000 people and a 1% chance of a false positive, there would be 10 people who could be positive. And if you do the math and you count having tested positive, it means you are 1 out of 11 possible people. 10 of those possible people would have tested positive and incorrectly so, and 1 would have tested positive correctly so. So you're actually 1 out of 11 people, and that gives us 9%, as I showed. So just maybe a graphical explanation of why we get to such a low answer. Now, many of you hopefully have read one or both of these books, and you will recall in Thinking Fast, Thinking Slow, Kahneman and Tversky did an experiment by asking respondents, giving them a little description about a bloke called Steve. And they described Steve as a bit of a nerd and an introvert. And fortunately, they didn't ask whether Steve is an actuary. They just asked whether Steve is a librarian or a farmer, saying if Steve is not interested in people and is meek and tidy and is a passion for structure and for detail, is he more likely to be a farmer or librarian? And many of you will recall that when this experiment was done, the vast majority of respondents, something close to 90% of people, said, no, I think it's most likely that Steve is a librarian. Kahneman and Tversky thought that this was an irrational response and said that maybe this suggests that people forgot to take into account the actual prior, shall I call it, ratio of farmers and librarians, and said that at least in the US, there are many, many more, almost 20 times, according to them, more farmers than librarians. And so people did not take this into account. We can show this graphically. Maybe let's say if it's true that there's 20 farmers for every librarian, let's draw a picture of 10 librarians, 200 farmers, and perhaps we can argue there's a 40% chance that a librarian would have the nerdy traits that Steve has, and only a 10% chance that a farmer has those traits. Yet if you do the math and you do the probability theory, the formula that I just showed you, you'll see that actually about 4 librarians and about 20 farmers fit this description. And so if we want to know that a random person fitting this description is actually a librarian, we would get to a result of 4 out of 24. You can look at the numbers a little bit later if you want. Or one way of showing it is that we have to take these 4 over here and divide them by this 4 plus this 20, because then we looked at the people who fit the evidence of being a nerd, but who are librarians. So this is really how Bayes works, is this maybe counterintuitive element that even though 40% of librarians fit this notion, there's actually so many farmers. And another way of thinking about it is to say your prior view is that there are so many librarians and so many farmers, 1 out of 20, which is about 4 or 5%, 1 out of 21. And so without the evidence that Steve is a nerd, we would have taken the probability of Steve being a librarian as about 5%. So What Bayes tells us, and this is perhaps one of the most important moral lessons coming out from this, is that evidence should never determine your beliefs, but it should update your prior beliefs. And maybe if I can emphasize one thing, and I'll give more examples just now, it's this one, that evidence in isolation is not useful in a vacuum. You must start with a prior view of the world. For example, one out of every librarian, where there's one librarian for every 20 farmers, one out of 21 people in this chain is a librarian. So there's a 5% chance of being a librarian. Now we get the evidence that Steve is a nerd. Once we have that evidence, it turns out that 16% chance or 17% chance of Steve being a librarian. Now in Bayes' language, and I'll show this a little bit more clearly now, we talk about this as the prior belief, and then evidence emerge, and we update our probabilities using the evidence to get to a posterior belief. So I hope I haven't bored you to death yet, but this is going somewhere interesting, I hope. So central to Bayes is that we can never know the world perfectly. All we can do is to continue to update the beliefs that we hold and update those beliefs as more evidence emerges to become increasingly more certain about how the world works. And it was actually meant to be used iteratively. What do I mean with iterative application? When Richard Price presented Bayes' theorem to the Royal Society, he actually said it's a little bit like imagining a cave dweller coming out of a cave for the first time in his life and seeing the sunrise. And then you could ask, well, this is interesting, this big ball of fire that comes up from the horizon, is this only going to happen once or will it happen again? And the next day it happens again, and the cave dweller says, okay, well, maybe this is something that happens every day, but I'm not yet sure. But after seeing 1,000 sunrises every morning, he grows progressively more and more certain, almost to the point of completely certain, that this is actually something that will happen again. So for the iterative approach, let's just think about our previous example where we said you tested positive and have a 9% chance of having the disease. So we had a prior of 1 out of 1,000. After testing positive, that increased to 9%. What Bayes now says is that this posterior belief, the increased probability, will now become my prior probability because I've updated the way I think about things. So let's make this practical and say, let's imagine after testing positive and realizing I have a 9% chance, I'm now going to go to another lab. I'm going to redo the test, maybe by someone else, a second opinion, just to be sure, which is a perfectly rational response. And let's suppose I go for this test and it is again positive. Well, what does that tell us? If we use the numbers, and again, we can take the denominator and express it as a little bit of a more clumsy and messy expression, but it just means the sum of a correct positive and a false positive result. We plug in these numbers, then we actually get to a result of 91%. So what Bayes says, initially, I thought it's like 1 out of 1,000. I then tested positive once and I had to update my beliefs. Now I have a 9% chance of having the disease. I went for a second test at a different lab independently, again tested positive. Well, 2 consecutive tests in a row becomes pretty sure that I might have this disease, and actually reflected in the mass by updating what we're looking at to 90.7%. So we have a prior view, some evidence emerge, we have an updated belief after 1 positive test, and we have another updated belief after 2 positive tests. So now, what does this tell us about anything? I mean, Christoff is rambling on about some rather rudimentary mathematics and trying to look quite smart by drawing H's and E's and vertical bars on the slides. But I'll give you 2 examples of why I think quite topical to today's world. I think Bayes is something that we all should pay more attention to. The first is correlation versus causation. All of us know that correlation does not imply causation. That's why if you have a hypothesis about a certain treatment for COVID, maybe you have to do randomized, double-blind clinical trials, controlled clinical trials, before you can argue that you've proved causation. There are so many jokes and so many examples of this. For example, ice cream consumption is highly correlated with drowning. So if you thought that correlation implied causation, you could say, well, people should stop eating ice cream and then we'll stop drowning. Or another Classic example around reverse causation is when someone said, every time I walk past a house or a building that's burning down, I see firemen standing in front of the building. That must mean that firemen cause fires. So if we can just take the firemen away, buildings will stop burning down. So classically, we understand correlation doesn't cause causation, but actually Bayes does give us a way to apprehend this. Because intuitively, like I said with the dice earlier, if you see evidence emerging again and again and again and again, you might want to say, well, maybe there is something here. And of course, you can only observe correlation. Before you do a double-blind, randomized, controlled clinical trial like an experiment, you can't prove causation. And that doesn't feel right. There must be something you can do to breach the enormous gap between correlation and causation. And this is actually what Bayes does. Bayes says to us that correlation can never prove causation, but actually, if you have a hypothesis that there is a causal effect, and every time you observe, if you're careful and you're a good Bayesian and you look objectively at the evidence, and every time you see an observation that supports this, you can become a little bit more certain that there is a causal effect. You can never be 100% sure. And maybe initially it would be like a rickety little bridge like the one below, but in due course, you might get a little bit of a stronger bridge. It will never be an infallible bridge, but as more and more evidence emerge, you can actually breach the gap. There are so many examples, of course, in healthcare. I recall in the health market inquiry where the panelists struggled with the question, is there a causal linkage between the way regulations require PMBs to be reimbursed by medical schemes and increases in PMB expenditure? And anyone working in the medical scheme industry would have said, of course there is, but the panel felt they were not convinced that there's sufficient evidence to postulate causation. Maybe the panel of the health market inquiry were not good Bayesians, because if they looked at the evidence through a Bayesian lens, they would have said, yes, we can't prove, but the probability seems pretty high that there is a causal linkage. Or let's take COVID treatment. So let's imagine you're a physician. You try some new drug, some kind of steroid. You see, well, the patient recovers. That's interesting. You try it in another patient. That patient also recovers. And you start postulating this hypothesis that maybe this drug works. Now, you don't have the luxury of going for randomized double-blind clinical trials or waiting for those outcomes, because you need to treat your patients. But every time you treat someone with this drug, treatment might fail, it might work. When it does, you use that evidence to update your belief system as to whether it works, and we can actually breach the insurmountable gap between correlation and causation through that. But, and there's a very big but, which is the second part of the so what that I will come to before I conclude. Bayes also tells us that you should never, ever, through this correlation causation gap, be 100% certain about any of your beliefs. And we can show this mathematically. So I said that we have this formula that tells us that we take a prior view and we update it using evidence. So in the example that I used, we said we started a 0.1% chance, but then I test positive and then maybe it becomes 9.1. Maybe I test positive again, it becomes 92%. Maybe I test positive for a third time and then it comes to 97 or 98%. If that's the case, we have this iterative ladder, but you'll notice that even as this percentage goes closer and closer to 100, it will never be 100, if I can appeal to the mathematician in you. The reason for that, what Bayes shows us mathematically, is if you hold an absolute belief, which could be either a 0% probability or 100% probability, then the maths work such that no amount of evidence will ever be able to change your belief. And I guess this is the profound and simultaneously obvious result that we need to remind ourselves of. You should never feel 100% certain about anything, if you, or 0%. Zero is the easiest to explain mathematically because you can take any evidence and multiply it with zero and you'll still be stuck with zero, which is why Bayes kind of gets stuck in these absolute realms. And we live in a world today where absolute beliefs are becoming more and more commonplace. I'm sure most of you have by now watched The Social Dilemma, and we've seen the evidence, for example, in the US, of a society becoming more and more divided because people consider only limited evidence that fits their prior beliefs and do not expose themselves, maybe because social media, according to the social dilemma, only presents us with evidence that we like to see, but never expose ourselves to contrarian views. And as a result, people are drifting further and further apart. And you get to the point where people hold absolute beliefs about politically sensitive matters or religious matters, and no amount of debate or evidence would ever be able to convince someone like that. So it is vital to keep exposing ourselves to contrary evidence and weigh this carefully through the Bayesian process and testing the validity of our own beliefs. Now, you can ask me, Christoff, does this mean that I shouldn't believe that the Earth is round? You know, because there are flat earthers, and apparently they're increasing in prevalence at an alarming rate. And my response to you would be actually yes. I think even if someone asks you, is the Earth round or flat, the right Bayesian response would be to say, I'm pretty darn sure the Earth is round, 99.9999%. But actually, I'm willing to leave that tiny shred, that crack of the door open for evidence emerging that maybe, I don't know, maybe that's not the case. And if the evidence emerges, I will consider it and I will update my belief. But the vital part of never, ever holding an absolute belief is what Bayes tells us. I think we can also see this in the South African history, where if Mandela had the belief that it was impossible, he wouldn't have done this. He wouldn't have tried. He wouldn't have struggled. He wouldn't have succeeded. And his infamous quote about it's not impossible until it's done is talking about a Bayesian approach, is to say, well, actually, it seemed maybe improbable, but certainly not impossible. And now that it is done, we can look back with the new evidence and update our prior beliefs and say, actually, it was possible, maybe with a higher probability than we thought. So to conclude, a bit off topic, a bit different from usual, but I hope you would have found this a little bit interesting. Some mathematics and some probability theory, just saying there are different ways to think about probability. Some probabilities are actually result in personal beliefs. It's inevitable. We all hold those beliefs. We might hold different beliefs. We might hold different prior beliefs, and that's perfectly fine, as long as we are all willing to update our beliefs whenever evidence emerges. Evidence should never determine our beliefs in isolation. It should update a prior belief. So in other words, if the physician tries a certain treatment on a COVID patient and it works and you have this positive evidence, that positive evidence can never be applied in a vacuum. It should be applied to the experience that you had in the prior view that you had prior to that the medicine might work, and updating this iteratively. Importantly, Bayes can breach the insurmountable gap, and I can't stress the significance of this enough, between correlation and causation, because in everyday life we are often confronted with examples of where we need to figure out what causal effects are, but we will never have the luxury of doing double-blind experiments. And so Bayes helps with that. And I've also talked, I guess most importantly, and I guess quite relevant in today's political world internationally, is that we should never hold absolute beliefs. We should always leave a little bit of doubt for evidence to persuade us that we might be wrong about something. There are other applications of Bayes, especially in science and in machine learning, that I'm not even touching on. You wouldn't know it, but your spam filter in your email also uses Bayesian theory to update itself every time that you say this email was actually not junk, or this one is junk. I guess you can imagine how that works. But I thought when we discussed Foresight that this might be an interesting topic just to share some mathematics and some beliefs and some philosophy of what Bayes taught us about the world. And I hope many of you would have found this as interesting as I do. So thanks, Zelda. I guess we can move on to the next presentation. Are we going to have Q&A at the end, or what is the plan?
Yes, thanks, Christoff. We'll have Q&A right at the end again. So we're going to move on to Lwazi and Lube now. So Lwazi and Lube have quite a long presentation. So maybe if you want to grab something to drink quickly or get a coffee while I'm introducing them, maybe Lwazi can just start to share his screen so long. So we have Lwazi and Lube speaking about the economy and mortality. And this presentation came about, when we came into the COVID-19 pandemic, and we were kind of thinking about looking at when there's a downturn in the economy, how that might affect mortality and the COVID deaths that we've seen. Can we also explain some of the other deaths that we've seen, the downturn in the economy? So that's brought on some of this research. So Lwazi and Lube have spent quite a lot of time doing literature reviews, and based on Christoff's presentation, also trying to think about, are there just relationships here that are showing a correlation, or is there enough evidence to draw out a more causative relationship? They're going to discuss that a bit. And I also just have to commend Lwazi and Lube for putting all of the hard work and research into this presentation. They've also been busy with exams and all of their other normal work and had to deal with this on top of that. Lwazi just had an exam on Friday, so he had to do a lot of preparation before his exam and finish off some preparation yesterday for this presentation. And Lube also had an exam not too long ago. So just well done and thanks for all of the hard work. I'm going to hand over to Lwazi now to start us off.
Good morning, everybody. I hope you can hear me and see the presentation properly. So the title of our presentation today is we are considering the socioeconomic effects of economic contraction, and particularly due to COVID-19. To give you a bit of a background to our presentation, so since the beginning of the COVID-19 pandemic, governments around the world, they have taken some sort of measures to try and combat the pandemic. Those measures have included requiring the wearing of masks, social distancing, limitations of travel, local and international, and limitations of public gatherings, and so on. But most prominently, governments around the world have almost universally implemented some form of lockdown, whether a national lockdown or a regional lockdown, right? And those lockdowns, they have came with very significant shocks to economies around the world because they've suspended economic activity in very large proportions of economies all over, right? So these measures were intended to slow the spread of COVID-19. And the justification was that if we can pull this off, then we can improve the health system readiness and prepare it for a almost inevitable surge of COVID-19 cases, right? If we come back to South Africa now, by international standards, our lockdown was implemented very early, right? And it came with a slowdown in daily COVID-19 cases and a slowdown in deaths, but also it came with a very massive negative shock to our economy, right? Now, our economy is characterized by very high levels of unemployment and high levels of inequality. In addition, very large parts of our economy are informal. So this includes industries like the minibus, taxi transport, and various forms of street trading and so on, right? So given our unique circumstances, there's been growing concerns that the mortality and morbidity effects of economic contraction due to the lockdowns might actually outweigh the COVID-19 specific deaths. So given that background, in this presentation, we review the literature, right, that is trying to associate variations in the economy with variations in health, right? We try and look at whether there are any causal relationships that we can infer from the evidence, right? And then from that point, we try to consider this from more of a population perspective, looking at population studies, and then we look at whether we can look at it from a micro economic perspective, right? And then further, we look at socioeconomic experiences in South Africa through the COVID-19 pandemic, and then we try to consider the different modes or channels by which the economy possibly affects morbidity and mortality. This is considering things like poverty, nutrition, mental health, and so on, right? And then finally, we try to make some informed speculations on how COVID-19 may have affected us positively in the long term, particularly with regards to government policy. Right. Now, to start off, we asked the question whether we can predict the effect of the business cycle on health. Right. There are various theories that are proposed to try and answer this question, and one of the most prominent ones is the Preston curve. So the Preston curve was discovered, or it was specified in 1975 by Preston, and what it shows is a concave relationship between income in terms of per capita GDP and life expectancy. And we see two cross-sectional plots there in 2000 and 2018. And we can see the relative position of South Africa over there around Namibia, Botswana, and other countries. And we can see how we have moved about 18 years later. Right. So looking at this picture, we ask ourselves one big question, whether this implies any causal relationships, because very clearly we can see the poorer countries tend to have lower life expectancy than the richer countries. Right. And the answer is, from the evidence that we surveyed, it does not imply any causal relationships at all. Right. So in other ways, we cannot really say by looking at the Preston curve that if our GDP per capita would reduce by some factor, then life expectancy would reduce by some complementary factor. And the reason is that if we look at the various cross-sectional plots of the Preston curve from the 1970s all the way to today, this concave picture keeps coming back again and again. And that is, the concave picture keeps coming back even when we have the poorer countries gaining a lot in terms of health and the richer countries gaining a lot in terms of income, right? So by the fact that it continues to creep back and be concave over a long period, it does not really imply that there is a there is a concave relationship between income and health within individual countries. Other theories that are usually proposed are the ones involving the social gradient in mortality, right? And what this theory basically means is that people of lower socioeconomic class tend to have higher mortality. And also people of lower household income tend to have higher mortality, right? And of course, people of higher socioeconomic class and high income tend to have lower mortality. But we ask ourselves that even though we can notice this picture, if we were to do a cross-sectional investigation of socioeconomic class, income, and mortality or morbidity, we ask ourselves whether there is any implication of a causal evidence. And the answer is, unfortunately, we do not find any implication of a causal relationship in the evidence. And we are going to see later why we don't. Right. Now, moving on from the theories to try and survey some historical observations. So the massive contraction in economies around the world due to the COVID-19 is not going to be new. We've experienced all sorts of massive financial crisis or economic crisis and great recessions in the past. So we try to see what we learn from them. If we look at North America and largely much of the developed world and look at their experience through the 2008 financial crisis, we try to see whether the crude death rate per 1,000 in the country responded to the massive reduction in GDP per capita, right? If we look at the United States, they're leading up to 2008, they had a decreasing trend of their crude death rate per 1,000, and they had an increasing trend of income, a steadily increasing income. And from 2007, they started to experience a decrease, which reached its trough there in 2009. But if we try to see whether we can relate that to the crude death rate, what we see is that the crude death rate actually started increasing from 2009 to 2010 and so on, when the economy started to recover. And actually, this picture is very common throughout the developed world. And even when we look at other previous economic crises, what we find is that as the economy starts to recover, we see mortality actually increases in these countries. And the question then is, why do we see this picture? Some researchers have proposed various reasons, and one of the reasons proposed is people have more time to exercise and to spend on leisure and to focus on themselves and their well-being if the economy is in recession, because they are working less, right? There are less car accidents because people are working less and they are traveling less. And actually, mortality due to car accidents is actually very significant in various countries. So because people are driving less and there's less industrial activity, what we find is there's less pollution also. And obviously there should be less work-related accidents and there should be less work-related stress. Right, so all these factors contribute to mortality actually decreasing during recessions. Moving on now to try and focus maybe on developing countries, right? So remember, we are looking here at, we try to look at population observations to try to see what happens to the country as a whole through economic crises. So the 1990s East Asian economic crisis started in Thailand. The epicenter was Thailand. It started when Thailand devalued their currency, which was previously pegged to the US dollar. So the devaluation of their currency actually led to a massive shock to their economy. We can see that GDP per capita in Thailand, it peaked there in 1996 and then it started to drop and it reached its lowest point in 1998 over there. But then we try to see whether the crude death rate responds to this massive and very significant shock that we see to their economy. And we don't really see a particular response. And this is actually very common throughout other East Asian countries, including Indonesia, Malaysia, and Singapore. Another informative and highly cited example is that one of the dissolution of the Soviet Union. Now, if we consider the Soviet Union for a second, it was a country or an empire, or whatever you want to call it, which was very centrally run at its peak. And what they could do is they could take some diversification advantages over the different little territories and the component countries. And what they could do in order to produce, they could do whatever it is that each individual country was well positioned to do or to produce, right? When the Soviet Union was broken up, what happened was each country did not really have the infrastructure. It was not well positioned to actually run its economy independently for its own people. So inevitably, among all the former Soviet Union countries, what happened was they had a massive shock to their economies and they had a massive drop to their GDPs. So we can see it starting there in 1990, if we just focus on Russia for a second. And we see it was at its lowest point there in the late 90s. And we ask ourselves whether we can see any response in the mortality rates due to this massive shock to the economies. And we can't really find any discernible response. And this is actually very common through many former Soviet countries, including Ukraine, Kazakhstan, Belarus, and even others that I did not specify over here. So the evidence is largely inconclusive. Other two very famous examples, highly cited examples in these studies is that one of China and India. If we focus on China and try to look at whether the pickup in economic growth in the 1960s actually contributed at all to their health. And what we find in China is that the health gains largely preceded economic growth. On the other hand, if we try and just focus on India in the 1960s all the way to today, it appears that if we look at a longer period now, not just focusing on economic crisis, what we find is that economic growth appears to have contributed to their gain in health very early in the 60s and in the 80s. But then later, as the economy has really boomed, it has improvements in health have continued, but they've become stagnant compared to the economy. Now, if we just come back to South Africa, right? On the picture on the left over there, we look at GDP per capita versus life expectancy, and then we try to really think whether we can discern any relationships over there. If we look at our life expectancy, we had a steady increase from the 1960s all the way to the 1990s, even though we had variations in GDP per capita, right? And from the late 80s there to the 90s, we see a massive shock to our life expectancy. And that is roughly as a result of HIV, right? That is a result of HIV. And we can see that we had the whole experience with HIV denialism and the slowdown in implementing some intervention measures. And due to the HIV problem, we lost about 10 years of life expectancy, right? But through that whole period, we can see from the late 90s all the way to today, income largely increased in South Africa, though marginally, but it largely increased. And we can't really see much of a discernible relationship if we just look at this picture. And on the left over there, we try to focus on unemployment rates now and life expectancy. And a similar issue here, we see the unemployment rate following just its own trajectory that does not appear to be related to life expectancy, right? Now, some of you might be disappointed at this point that I was just doing very simple two-way comparisons over there, right? But of course, you don't really do statistical studies that way, right? But that speaks to the limitations of the literature and the different studies that we've had so far in the field. Firstly, there isn't enough research, and even when there is some research, there is rigorous research, but arguing for completely contradictory positions. And there's the issue of data quality and measurement errors, right? So there isn't proper like births and deaths registrations, especially in the developing countries that we're trying to look at and trying to see where South Africa fits in the picture. And more importantly, there's the issue of unmeasurable confounding factors, right? If we just look at South Africa, our variation in GDP and life expectancy, we might find that actually there is the HIV problem that we had. There was a confounding factor, but HIV is not the only one. There are issues of inequality. Inequality has been proven to some extent to affect these relationships. There are things like climate, and I mean I could list a whole lot of things. A lot of these factors, they are not measurable, right? So we cannot really quantify them and put them nicely in a statistical study. And then there's the issue of reverse causality, right? I think it is self-evident that income affects health in the same way that health affects income, right? We can imagine a person who's sitting somewhere in a hospital bed and they're not working, right? And because they're not working, they're not earning any income. And so in that scenario, their status of health affects their income. But then we can also imagine a person who starts out healthy and we deprive them completely of any sort of income. They're not going to have access to proper nutritious food. They're not going to be able to access all sorts of health services. And so we can expect their health to deteriorate as a result of their low income. And so we ask ourselves, what direction of this causality is important, right? Which one is mostly manifested in reality? Because of all these factors that I've highlighted, we can't really say. And then finally, there's the issue of micro evidence kind of contradicting macro evidence or the population studies. So by micro evidence, I mean evidence relating to what happens to people when they lose their jobs, what happens to people when they lose their income. We can obviously say that probably their health deteriorates, but we ask ourselves, what happens for a whole population if some people lose their income, right? What happens overall? We really can't say. We really do not know because of all these intermediate factors that are very difficult to measure. So at this point, we are going to move on to Luba, who is going to explore our socioeconomic experience so far with the COVID-19. And she's going to be looking at the different modes by which the economy is expected to affect health, including things like poverty, income and mental health, and so on. Over to you, Luba.
Okay, so in order for us to develop an understanding on the micro effects of the shocks in the economy, we conducted an analysis on the impact of COVID-19, how it has affected the lives of people in South Africa so far. And in order to do this, we used data from the NDIS CRAM survey. So considering the survey results on loss of employment, respondents were asked if they had had a job or a business in February and if they still had this source of income in April. 40.1% of respondents said they had lost their source of income. 90% of respondents said they lost their income due to the lockdown. And over 70% of respondents who had lost their income had been earning less than 6,000 Rand per month in February. This is much larger compared to only 2% who were earning more than 2,400 Rands in February who said that they had lost their jobs. So this highlights that during these times when there's a lockdown that affects economic activity, those who are most vulnerable, those who are taking home much smaller paychecks, are usually the most affected. So then looking at the survey results on hunger, respondents were asked in April if they had experienced hunger at all over the past 7 days when the survey was being conducted. And 26% of the respondents said they had experienced hunger in the past 7 days. And 32% of respondents who had experienced hunger had been earning less than 6,000 Rand per month in February. And this is also much larger compared to the 1% of respondents who were earning over 24,000 Rands in February who said they had experienced hunger. Then considering the survey results on child hunger in particular, respondents were asked if they had children in their households and if those children had experienced hunger in the past 7 days in April. 19% of respondents said their children had experienced hunger in the past 7 days. 32% of respondents whose children experienced hunger were earning less than 6,000 Rand per month in February, and only 0.02% were earning over 24,000 Rands per month in February, again highlighting the point that the impacts of an economic downturn are not evenly felt. So when we compare what we are seeing in South Africa, what happened during lockdown, and we compare this to past research, we find that these findings are in line with past research, mainly that the impacts of a lockdown in an economy are not evenly distributed. During recessionary periods, as unemployment rises, the problems that were already facing the poor that are related to inadequate earnings tend to get worse. So Lwazi has already summarized these results at a macro level, but if we split people by income groups, there is some research that points to differences in mortality rates. So in particular, during the financial crisis, the recession affected low-income Americans severely. The unemployment rate between 2006 and 2008 rose to 6.5%. However, during that same period, unemployment rate for low-income groups increased from 6.3% to 10.3%. And the loss of employment was found to lead to prolonged levels of stress, which also increased the risk of mental health issues and opioid abuse. Studies have also shown that small differences in income have been associated with much larger changes in health status among the poor as compared to wealthy families. So poor groups of people have been found generally to have 2 to 3 times higher death rates than those of higher financial statuses. So essentially, studies do point to some extent that there are some socioeconomic mortality and morbidity differences. The main factors that have been argued to be responsible for a large part of these differences are money, education, social capital, the healthcare system, stress, and behaviors. So money can buy healthy food. It can allow the individual to afford good housing, better medical treatment, and other goods that are relevant in maintaining good health. And then education, it allows people to gain knowledge about health risks and healthy behaviors. It also gives them an opportunity to improve their socioeconomic status. And social capital is helpful when a person needs information and emotional and practical support. And then stress is likely to be higher, and health behaviors tend to be poorer in low status groups. Then the healthcare system, it determines the level of access to quality healthcare that people from lower socioeconomic groups have. We went further to look at how poverty and economic downturns, such as the one we're facing now due to COVID-19, how these downturns affect infant mortality in low and middle income countries such as South Africa. So looking specifically at how poverty affects infants and children, the main areas that have been found to be of great concern are child and infant mortality, malnutrition, high illiteracy rates, and low school enrollment. So child mortality and malnutrition is a global problem. There was a study done of over 200 countries across the world, and they found that the mean rate of child malnutrition was 17 children per 100, and the average child mortality rate was 70 children per 1,000. And the child malnutrition and mortality rates were found to be more likely to occur among regions that had a higher literacy rate, higher unemployment rate, more poverty, and they had a lower GNP per capita. The levels of malnutrition and mortality rates among African children were very high compared to the rest of the world. In particular, the average child mortality rate was over 130 children per 1,000 in sub-Saharan Africa, which is almost double the mean global average of 70 children per 1,000. So poverty and malnutrition are of great concern in Africa. And in fact, malnutrition has been found to be the underlying cause of child mortality in more than 54% of deaths in Africa. Malnutrition and poverty have been described as a vicious and intergenerational cycle where undernutrition and underdevelopment are both a cause and a consequence of poverty. So how this cycle happens is that pregnant women from low-income backgrounds are likely to face issues of food insecurity. This then leads to them being malnourished, and as a result, these malnourished pregnant women are likely to give birth to low birth weight babies. Low birth weight babies without catch-up growth then develop into stunted children and adults with reduced human capability. These individuals often lack the ability to get to benefit from education and to, at the end of the day, become economically productive. This then leads to them working in low-income jobs. That's if they are able to get employment at all. And then, as a result, they fail to create a set of circumstances that prevent undernutrition and poverty in their offspring. This leads to poverty and undernutrition becoming intergenerational. So essentially, the process of developing individuals that are healthy, educated, capable of creating circumstances for their offspring that break the cycle of poverty begins before these people are even born, and it continues throughout the life of that individual. To further emphasize that people from low socioeconomic groups are the most affected, a study in South Africa found that children from the poorest 10% of households had rates of underweight and stunting, which were 3 to 8 times more compared to those of the richest 10%. Improvements in household income were associated with significant drops of child mortality, with significant drops in the child being stunted and underweight. Stunting also leads to an increase in many non-communicable diseases, including heart disease and stroke. This is because stunting affects the development of their bodies, making them more susceptible to cardiovascular diseases. In South Africa, cardiovascular disease is a major cause of death, especially in older South Africans. So studies have shown that there is a link between poverty and cardiovascular diseases. So not only does poverty lead to stunting, people from low-income households struggling with food insecurity and joblessness tend to have less knowledge about cardiovascular disease risk factors, and they have little interest in primary prevention. They also have less access to treatment. So we have considered the poverty cycle, and we have considered general cardiovascular disease being a major cause of death. But additionally, we have seen during this time of COVID-19 pandemic, as some of our other colleagues have presented in earlier Foresight events, what we have seen is that people are avoiding healthcare. They're avoiding going to hospitals, they're avoiding visiting their GPs. And when they avoid the normal healthcare, and additionally to that, they have chronic conditions, this can lead to some of their chronic conditions complicating. And in some cases, that can lead to an increase in mortality, which we might see over the next few years. A study was recently conducted that identified over 2,000 excess deaths in England and Wales due to heart disease and stroke during the peak of the COVID-19 pandemic. The researchers believe the excess deaths were caused by people not seeking emergency treatment for a heart attack or other acute cardiovascular diseases requiring urgent medical attention. This was because these individuals were either afraid of contracting COVID-19 or they were not afraid, they were not referred for treatment. So now if we look particularly at the effects of economic downturns on infant mortality in low and middle income economies, studies have found that in poorer countries, child mortality rises and child school enrollment, as well as nutrition quality, tend to fall during recessionary periods. An analysis of middle income countries across the world found that the key factor in explaining the differences of child mortality is GDP per capita. So countries that had a 10 times higher GDP per capita had a 4.4 times lower child mortality rate. Studies also suggest that in developing countries, infants are more likely to die during negative shocks in the GDP, and on average, a 1% decrease in GDP per capita results in a 40% increase in infant mortality. So when we look at some examples from low and middle income countries, we see that infant mortality is counter-cyclical. Infant mortality rates tend to increase when GDP levels decrease. So in particular in Mexico, during the 1995 to 1996 crisis, we saw child mortality increase by 0.06%. And then in Peru, during their 1980s crisis, there was a 2.5% increase in child mortality. In sub-Saharan Africa, during the financial crisis in 2008, excess infant deaths were estimated to be between 28,000 and 50,000 deaths. And in Indonesia, during the 1997 crisis, child mortality increased by 3.2%. So it's worth noting that these observations are not uniform across all low and middle income economies. So in particular, just to bring your attention to what happened in rural Colombia, here infant mortality has been found to be pro-cyclical. So as GDP levels decrease, infant mortality has been observed to decrease as well. So this has been because the people in rural Colombia do have access to quality healthcare, and the quality healthcare is actually affordable for all. But the issue mainly is that in order to access this quality healthcare, they have to travel long distances, and even when they do go, they usually face with very long lines, and this results in child health being a very time intensive investment. So during periods of recession where people are losing their jobs, they actually have more time to actually go to these healthcare services and actually, and then this improves infant mortality. So based on our findings, what we have seen from the data and economic downturns in general, given the economic climate that we're facing right now due to COVID-19, how these things affect mortality and morbidity, we can consider whether there are some policies and some actions the government can take. So firstly, policies to improve financial situation of people should target the most vulnerable in society, those with low to no income, those who face issues of food insecurity, those who are vulnerable to job losses during recessionary periods. This is because during a recession, people are not affected the same. So what we have seen so far is that the government has paid out a special COVID relief unemployment grant of 350 Rand to individuals who are unemployed and do not receive any other form of social grant or unemployment fund payment. Additionally, we have seen that people who are already social grant beneficiaries, they have been given an extra 250 Rand per month for the period of May to October. So these grants properly target the most vulnerable in society, and the government should continue to further expand on these. So grants such as business relief grants also help businesses stay afloat during this crisis, allowing businesses to continue to employ people, thus reducing the possible levels of unemployment. To deal with the issue of malnutrition, intervention policies must improve the issue of food insecurity in low-income households. Additionally, interventions must also be focused at pregnant women to prevent the birth of low birth weight babies, which leads to physical and mental stunting. So far, we have seen the government has increased the child support grant by giving receivers an additional 300 Rand in May, and then it went up to an additional 500 Rand from June to October. And then we have also seen the Department of Social Development partner with the Solidarity Fund, with NGOs and other community-based organizations to distribute food parcels across the world, across the country. More efforts, however, can be made to target pregnant women to properly deal with the issue of malnutrition. So policies to directly look at the issue of mortality and morbidity should focus on the improvement on the coverage and the performance of the health system. So as we saw in rural Colombia, the reason why child and infant mortality was pro-cyclical, unlike what was observed in other low and middle income economies, was because there was access to quality and affordable healthcare for all. In addition to government action, individuals and communities can also help each other during these difficult times. We have seen an increase in social cohesion during this time. Firstly, during the pandemic, we saw the gang kingpins in South Africa actually coming together and agreeing to call a truce for this period. Maybe they felt the need to tackle one battle at a time. And not only did these gang members call it truce, they even came together to assist in the distribution of food and other supplies in their communities. We also saw drastic drops in violent crime during the first week of lockdown, comparing this time period to the exact same time period last year. Murder cases were 2 times lower, rape cases were 6 times lower, and cases of assault fell by 50%. We've also seen spikes in volunteering, as more and more people have signed up to volunteering websites. The social platform For Good saw a 250% increase in volunteer sign-ups since lockdown. So we wanted to also just bring your attention to this map called the Aqualay map. So this company created this map that plots little acts of kindness towards those that have been negatively impacted by the pandemic. So when you visit the map, it shows like pictures and videos and people telling their stories of the acts of kindness they gave or that they received. And this can be anything from calling a family member to donating food and to volunteering. So far, the map has shown close to 1,000 acts of kindness one of the people who uploaded an act of kindness that they received, Charles, spoke about being retrenched at the beginning of the year due to COVID, and his neighbor allowing him and his family to eat supper at their home until they were able to get back on their feet. Another user who shared their story, Angel, so she spoke about an act of kindness that she gave. And she runs a catering company. So during the period of COVID, she has been providing free catering for families that have lost their loved ones. Now to end off, Lwazi will just outline some silver linings that we are seeing so far.
Okay, so in this slide, what we've tried to do was to speculate based on what we've seen so far with in our experience with the pandemic, to speculate on how COVID-19 may have affected us positively in the long term. And firstly, there's been a massive increase in public health awareness among different people in the country and also all over the world. And there's been a massive increase in awareness, particularly in regional regional multinational institutions like the SADC and the AU. And we hope that this will increase focus in improving health systems in Africa and making sure that quality healthcare reaches people all over. Right. There's been an increase in public-private collaboration. We saw the private sector coming together with the government to try and solve all sorts of problems. A lot of those solutions were delivered through the Solidarity Fund that was established at the beginning of the pandemic. And what we hope is that in the future, there will be more willingness and bravery to tackle all sorts of social problems by the public sector coming together with the government. And we've seen an increasing emphasis on regional cooperation in Southern Africa and in Africa at large. And there's been a bigger focus on doing things locally, as Ramaphosa said. And what this means is, because of our experience through COVID-19 and a massive disruption in supply chains, we've seen a much larger focus in bringing back everything to the local market and making sure that future crises do not affect us in this way. And that is the end of our presentation. We wanted to highlight that we actually wrote a paper for most of the information that is presented here, and we are willing to share it with anybody who would like to see more or see anything in more detail. Thank you.
Thank you, Lwazi and Luba. That was a really fantastic presentation, and another great reminder that we should not neglect our youth in contributing to our debates and to society. And again, it's a privilege for Insight to be able to have such extraordinarily bright young talent, and we always relish the opportunity to give them the opportunity to speak to our audience like this. Thank you very much for all the time and effort you put in to the presentations, as Griselda mentioned, even during exam prep, and the effort shows. So thank you very much. Before I hand over to Christoff to handle the Q&A, I just wanted to say some general thank yous. First, specifically to Griselda, who really led the organization of our Foresight series this year. Obviously, we have to do everything differently because of COVID, but Griselda, thank you very much for all of your extra time and effort that you've put into the organizing and taking that burden off my hands. And then also, I'm sure Christoff will echo this, but thank you to our attendees, particularly those that managed to join for all 3 sessions. We really appreciate your engagement. and your continued relationship with us and interest in topics that we find interesting, even the super nerdy ones like Christoff spoke about this morning. We hope that you continue to find them interesting. Yeah, thank you very much for spending the time with us. Over to you, Christoff.
Thanks, Barry. Yeah, let me start by, just before we go to a quick Q&A, we have about 5 minutes left, but by joining Barry in thanking all of you. I've said this many times before, but it is super humbling to see a great turnout at these events, and we appreciate each of your attendance. It's not often that we have an opportunity to share some of our thinking and some of our research with an audience like this. Also to thank Griselda, who put in an extraordinary amount of work in making Foresight possible this year. Okay, what we're going to do right now is there are some questions. I'll start with the questions directed at me just to make things a little bit easier. But again, around 10 o'clock is the scheduled end of today. But in the past, we've seen if there is a bit of a lingering conversation or questions, we'd be happy to stick around for 5 or 10 minutes more if some of you are interested. But of course, if you start dropping off of the webinar around 10, we'll definitely not take it personally. So feel free to stick around if you have some more questions, maybe more discussion points. I'll just talk about very briefly, there's a question from Matthew Zylstra, who officially qualifies for our most active question asker person. And thanks for your participation, Matthew, really appreciate it. The first, I'm going to read the questions just for the benefit of those who might be watching on YouTube. So Matthew asked, how do you balance confirmation bias with Bayesian techniques? And it's a brilliant question. And just to be quite clear, confirmation bias is with us whether you like it or not. It's the reason things like clairvoyancy and superstition exists. So I had a grandmother who believed that if a pregnant woman carries the baby more to the front, then it must be a boy. And if you carry the baby more to the rear, I'm not sure how, then it must be a girl, or the other way around. I can't remember. But the reality is, my grandmother believed this, and I would argue that if only 1 out of 10 pregnancies conformed to her belief, that would have been sufficient to her to continue believing this, even if 9 out of 10 showed contrary evidence. So that's a great example of confirmation bias, because you want to believe something. It's commonly held for some people who like going to clairvoyance and have people peer into crystal balls and tell you about your future. I hope I'm not stepping on any toes right now, is that only 1 out of 10 predictions need to become even remotely true for the customers of clairvoyance to believe that these are accurate and useful sessions. And so I think there's a short answer and a longer answer to Matthew's question. The short answer is that the beauty of Bayes is that it gives us an objective and probabilistic and numerical approach to deal with these things. But the longer answer, perhaps, Matthew, is this. I think, let me put it like this. It is okay for all kinds of bias to be introduced in our prior beliefs. In fact, the prior belief, I think, is a reflection of bias, of belief, of subjectivity, and different people will have different beliefs and different priors. What is vital, though, is that we keep bias out of the evidence that we weigh. And of course, that's difficult because we are human beings. But so it is not okay for bias to affect how we see evidence. It is okay for bias to affect how we see our prior belief. And there are many examples that we can go into, but I think that's the short answer. And of course, it's easier said than done because we want evidence to show something quite often. We often invest it in our own beliefs. The doctor who's trying experimental treatment on COVID wants it to work and might cling on to very thin excuses for the instances where it did not work. And that would be an example of where you taint the evidence that you bring into consideration. Gary also asked whether we shouldn't regard randomized trials as not a luxury, but a necessity. Of course, I would agree with that, but the reality in practice is if you're a doctor in April 2020, with a COVID patient in front of you, there is no opportunity to think about luxuries. You have to do what you have to do. And in the interim, until you have the causal proof that comes with a proper double-blind, randomized, structured clinical trial, Bayes is a useful, I guess, crutch, provided, like Matthew said, that you don't look at tainted evidence or taint your own evidence. It's a useful crutch to help you start updating beliefs as to bridge the gap between correlation and causation. I'm going to, the next questions are for Lwazi and for Luba. So for either of you, again, there's one question from Matthew and one from Sarah. And I'll read the questions again just for the benefit of people watching online. So Matthew is asking, says, you have provided information for me to update my beliefs on correlation between GDP and mortality. So Matthew is a good Bayesian, and we should commend that. He's asking, how do you think we could ensure that all the good work that is done to support our fellow South Africans is not undone by greed and corruption that raises its ugly head again during the pandemic relief efforts? It's certainly a loaded question. I'm not sure if Lwazi or Luba wants to take a stab at it, or anyone else on the panel.
I think
I don't see any volunteers. Lwazi?
Well, we might actually have just a tiny bit to contribute over there. I think through our experience with the pandemic and all the corruption that has been revealed with the whole 500 billion relief package that was announced, and the whole PPE procurement corruption and stuff, I think our experience through those challenges have highlighted the weaknesses in the regulations and in the procurement and public finance laws that we've had, and the sentiment has been echoed even within like the ruling party and even by President Ramaphosa himself. So I think we can only just learn by experience, and from our experience we can expect things to maybe even marginally improve, based on our observations. But maybe if we look in hindsight, it's hard to say.
Thanks, Lwazi. Maybe also just to comment there, I think a lot of countries are dealing with issues in terms of spending on COVID-19, not only South Africa. I think there are other countries, who have spent capital building field hospitals that weren't used, not only South Africa. So I think it's an issue that everyone's dealing with. But of course, corruption is something that we as a country have been dealing with for many years. But then we also have a question from Sarah. So Lwazi or Luba, this is for you as well. And then I'll just read it out for everyone's benefit. So she says, thank you for sharing your research. Have you looked at the impact of private sector versus the public sector in South Africa? In the UK, they talk about the postcode lottery, which refers to regional variations of care in the NHS. And as unemployed people can no longer afford private care and rely on the already overburdened public sector in South Africa, what will the impact be on healthcare and mortality? Lwazi and Luba, this one's for you. I don't think Lwazi and Luba have looked at specific research here on the private sector versus the public sector, but I guess we can speculate that, of course, if people don't have access to private care and there's an overburdened public system, that that will lead to a reduced or an increased burden in their morbidity. Lwazi and Luba, I don't know if you want to add any further comments there.
I think maybe just to add on to that, as much as we don't really specifically look at that in particular, we can also see from past research that there will be issues with regards to the quality of healthcare that's available to people. So with regards to people not having access to private healthcare, if the quality of public healthcare becomes poor, we can also start seeing even higher mortality rates, because even those people who can afford quality healthcare are now pushed out of the spaces that they could afford, and then being pushed into spaces of poorer quality healthcare.
Again, maybe just to add some other comments there, I think, similar to what we have, what you see in the UK with regional variations, we do also have that problem in South Africa. Some regions have, taken on telehealth care and have been able to still get care to people by using online platforms, but that isn't possible in all regions. So again, I think we also deal with that problem where in some regions you might have better access to care than other regions. So thanks, Sarah, for that question. So that's all of the questions that we have on the Q&A chat. But again, we have had people raise their hands to join and ask a question live and interact a bit. I don't see any hands raised at the moment. So maybe, I don't know if anybody has anything else that they would like to bring up to the discussion. Maybe I can just give you a second to raise your hand. If I don't see any raised hands coming up, then I think we'll probably end our session there. And just to say that next year, hopefully we can have a live event next year, but we could possibly still have some online foresights leading up to a live event next year. So please look out for that next year. Okay, I don't see any raised hands. So thank you everyone for joining us, and we look forward to our Foresight events next year. Hopefully we can see all of you in person next year so we can have more interactive discussions, but we have enjoyed the limited interaction that you have tried to share with us through the online platform. So thank you. Thanks everyone.
Thank you very much, everyone, and have a great day. Cheers.
Cheers.